Hello everyone, welcome to my YouTube channel. In this video, I will explain you how to do an AC to DC converter, let's say adapter. And let me first explain you the parts basically. Firstly, we have a transformer. In the transformer, we are stepping the voltage down to another level. And then we have a diode bridge. In the diode bridge, we can do a rectification. After the diode part, just after it, there is a capacitor, and the capacitor is tasked to smooth the voltage out actually, so that the voltage has a DC characteristics, and then the voltage is coming to the LM317 circuit. In the circuit, the LM317 circuit is used for decreasing the voltage. Again, we decrease the voltage again, and finally we obtained a desired voltage level, which is 15 volt. And 15 volt is the sum of numbers in my student ID. So that's why I needed to arrange it 15 volts at the output voltage. Yeah, my content is like that. And let me start from the beginning. We have a voltage source here, and let's show you the details, the features of it, the values of it. I'm using the sine wave, and the amplitude is 311 and the frequency is 50. Normally the input voltage is supposed to 220, but we were not allowed to do that directly. So that's why I'm using internal resistance to decrease the value. And I'm using 330 milliohm for making it as 220 volts. Let's see how it works. Yeah, this is input voltage. The voltage level is almost 220, so there is no problem. And after that, we are in the transformer part. In the transformer part, we are required to uh, step the voltage down to a level that LM317 can receive actually, because the LM317 can just have maximum 37 volts. That's why we cannot have more than this value. So we just decrease the value to 37. After the transformer part, we have come to the diode bridge. In the diode bridge, as I said, we are doing a rectification process. Let me show you. This is the last part of the situation. We just stepped the voltage down. After that, in the rectification part, the process is like that. With the diode bridge and capacitor, we have something like that. Let me explain you the graph. In the graph, the voltage gains a DC characteristics, but there are some up and downs. This is caused by the charging and discharging periodically of the capacitor. But when we increase the value, we can see the difference. Yeah, the ripple voltage increases. The ripple voltage is the difference between the up and down. So it's better to make it 100 macro farad actually. Yeah, this has a better appearance and look actually. After this part, we have something like that. And in the LM317 circuit, we are decreasing the value to the desired level. Now we have almost 37 volt, but we need to have 15 volt at the end as an output, right? So by using the resistors, the resistor values, by the way, I set an example in the datasheet for the circuit. So I just applied the circuit there to here, and I am changing the just this one. This is like a, let's consider it as a potentiometer, and I changed, I increase it to have a desired level. And in the last part, you can see that 15 volts here. At last, we have 15 volts. Let me show you again, and let me show you the steps. First this, then this one, then this is the blue one is rectification, and red one is, no, blue one is after transformation, stepping down. Actually, the red part is after diode bridge and capacitor, and yeah, the light blue one is the last version of the voltage level, which is output voltage. But I have another circuit that I was trying to do the bonus part. In this circuit, I just connected an resistor in parallel to the circuit to show the current, actually, to show the current as a 1 ampere. But it didn't work properly, because when I add this, the problem is that the voltage level has changed. Let me show you. Maybe you don't understand it very well. Just a second. Yeah. This part is the same, actually. They are the same, but this part is different. This part is not 15 volts. It's just 11 volts, because I've added the resistor here, and it has changed the, I think, equivalent resistance of the parts of the circuit, because the voltage arrangement applied by LM317 depends on the voltage ratio between this one and this one. It's the ratio between R3 and R2, I mean the resistors in this part. And when I add another additional resistor, the relationship has changed, in my opinion, and that's why the voltage level has changed. And when I measure the ampere through the resistor, we can see that it's almost 720 milliampere, and it's not 1 ampere, because the voltage level has changed, has decreased, as I said before. And that's all. Thanks for listening. Thanks for spending your time. See you later.